Here is a typical road in Bristol in the south of England. It's lit with sodium lamps, more precisely low pressure sodium lamps or SOX lamps. But why is this type of light so widely used in the UK? Why does it shine with a golden yellow light and not a white light? Why has it been used since the 1930s? This programme aims to find out.
Now, looking at that opening clip, you might think that the colour of the light from those street lights wasn't actually all that golden yellow. Well, here is a problem that I have in making this programme. I'm using digital imagery, as I would do nowadays, and digital cameras, including video cameras, don't actually capture the colour of SOX lights all that well. The actual colour that I'm trying to show to you is this. This is the actual golden yellow colour of SOX light from a SOX street light.
This photo was taken using an analogue camera back in 2004.
The camera was similar to this one. You put a 35mm film in the back and you take analogue photos, and cameras like this were able to capture the true colour of light properly, but digital cameras aren't able to. So the actual colour that I'm trying to show you is this. This is what a SOX street light produces. This has been warmed up for a few minutes. This is what they look like, this right hand photo, when they've just been on for 2 or 3 minutes. And then if I go over the page, a couple more there when the street lights have just been switched on.
Here are those photos again close up. The lamp switches on, shines a deep red colour, goes through its warm-up process and after a few minutes reaches its final yellow colour.
So, as mentioned at the start of the programme, SOX street lights have been in use since the 1930s.
The history of the sodium lamp effectively started in 1919, when the scientist Arthur H. Compton patented its design. For the next few years during the 1920s, he had to make further design refinements to the glass to make it more sodium resistant, because sodium is highly chemically reactive. But he overcame those, and in 1931 the first installation of sodium lights took place. It was in Berlin. The following year they appeared in the Netherlands, and then in December 1932 it happened for the first time in the United Kingdom. In Croydon, on Purley Way, close to the Philips lighting factory, we saw the first installation of sodium street lights in the UK. Between the 1930s and the 1960s, further design refinements were made. For example, further refinements to the glass to make it even more sodium resistant and to reduce staining. The tube was also modified to make it more efficient, and energy efficiencies in general were greatly improved. The housing of the design was also improved to direct the light to where it was needed, and also to keep good heat insulation and keep the operating temperature close to 260 Celsius, which was the essential level. So by the 1960s, the term SOX came into being and the lighting source was well established, but it was still only being used mainly on main roads and motorways. That changed with the 1970s energy crisis, and this is where the energy efficiency of SOX really benefited it as a lighting source. It became much more widely used on side roads as well. The fact it was energy efficient just meant that for many it was the lighting type of choice. And this continued into the 1980s and 1990s. SOX just became almost ubiquitous. In more recent years, since the millennium, it has been somewhat in decline. But it is still being manufactured by Philips, and we still see quite a lot of SOX street lights up and down the United Kingdom. I don't think you're ever really that far away from them, even nowadays, even in small pockets. And there are some fairly large networks still around. So, from the 1930s, with the boxy, very heavy, bulky designs, we now have much sleeker and more refined designs nowadays. So, that's a little bit of information about the history of SOX street lighting. Now, let's take a closer look at how they work.
Here is a lamp from my own collection. It's a 35 watt, pretty standard Thorn Beta 5. You'll see these lamps all over the place up and down the country. This one's a scaled down version in terms of the lamp post. Normally these lamps would stand about 4 metres tall, but this one's about 1 3/4 metres, 2 metres, obviously just to be able to fit inside my house. It's one I had made especially for me just over 10 years ago, and you know what, I'm pretty proud of it really. I think it looks really nice. But anyway, here's a lamp of my own which I can demonstrate a few things to you with. Let's open it up and take a little look inside. Okay, so inside we've got the lamp tube here. This is where the light is actually produced. And I've got another one here that's just the same, just to show you. So it's, let's see what we've got then, shall we? We have got 2 levels of glass in the tube. We've got an outer layer of glass, and we've also got an inner layer, a sort of U-shaped layer there. We've got a couple of electrodes at this end, standard bayonet fitting just like you would have with light bulbs. You've got a bit of sodium inside the tube. There's also some neon and argon. I'll talk about that later on, what they all do. What does the term SOX actually stand for? Well, the S in SOX stands for sodium, because it's actually sodium that's giving off the light. The O, it's a little bit debatable, but it seems to reflect the fact that you've got a bit of an O-shaped loop. It's more of a U-shaped loop really, isn't it? But kind of an O-shaped loop thing going on there. And then the X represents oxides. Now there's in particular an oxide that's on the inner surface of the outer tube, which is there for heat insulation. It's actually a vital thing that this lamp, when it's running, is kept at a constant temperature of 260 degrees Celsius. That's the optimum operating temperature. If it's any different, then the lamp just won't work as efficiently. So it's actually all a pretty precision piece of engineering. There's a lot of research and development that has gone into this over a period of a few decades. A lot of work, a lot of technology. This is really the technological hub of the whole lantern. The rest of the whole setup is fairly basic, as I can show you. Just above the tube we've got one of these. There's a gear tray that's just above, so this is the same model. I just turn it around the same way, and this has got some fairly simple components inside. We've got a ballast, which is there to keep the current at a constant level. We've got an igniter, that's there for when the lamp's starting up, to get it switched on. That's pretty standard for any fluorescent lighting tube. And we've got a capacitor, which is the least important of the three, but it's just there to make sure that you don't need to draw any more electric current than you have to when the lamp's running. And then your wires just to connect it to the mains power supply. So the basic idea of operation, which I'll come to in a bit more detail, you've got some sodium in a tube and you put electric current through it, it gives out light. Okay, let's put it back together, shall we, and switch it on. For a moment. And there it is. And what you won't be able to tell from this lamp at present, because of the limitations of digital camera technology, the lamp's actually shining red. Doesn't look it, does it? But it is. To me, it definitely looks red. Now, the reason for the initial red colour when the lamp switches on is a mixture of neon and argon. So there's not just sodium inside this tube. You've also got neon in particular, which is there to get the lamp started from cold. Without it, the lamp wouldn't start. because the sodium is solid and it needs to be vapour. So, the neon is there to start the lamp off. After a few minutes, the lamp slowly warms up and it gets to the point where sodium vapour can be produced. The lamp gets hot enough, it gets near to this 260 degrees Celsius level. You get sodium vapour being produced, pass an electric current through that, and you get the light that you want, the sodium light. But in the meantime, and you can't tell this yourself, but I can, the lamp is shining red. It's just like a neon sign at the moment, until it gets properly going. So, there you have it. It's not all that bright really. So, here's my SOX light. It's fully warmed up. Here it is. I've also turned out the other lights in the room just so you can see the colour of the light properly. So there it is, all nice and shining. I've got a few items on the table next to me here. This is a red book. This is yellow. This one is green. And this item is blue. Now, none of the colours actually show up very well. And this is one of the disadvantages of this colour of this colour of light, this type of lamp, because it's only giving off one colour of light, then you don't see all these different colours. Everything just appears grey or black, which can be fine for outside lighting, but it's not ideal. So why is SOX light so popular with people who do street lighting installations? Well, there are a few reasons. The light given off actually just happens to be very close to the peak sensitivity of the human eye. The eye is most sensitive to light with a wavelength of 555 nanometers. Now, 1 nanometer is 1 billionth of a meter. It's just a measure, a unit of measure of wavelength. So the human eye, most sensitive at 555 nanometers. The light from a sodium lamp is 589 nanometers. It's not a lot different, which means that humans are actually quite a bit more sensitive to SOX light than some other animals. To some animals, these lights really don't seem very bright at all. They seem very dim. So that's one reason. Another reason is that these are really efficient. For the amount of energy that you put into one of these lamps, the amount of light that you get out is quite a lot. There are other reasons as well. I'll go into them a bit more later, but there are good reasons why SOX is so well used.
This series of photos taken with an analogue camera shows the warm-up sequence of all SOX street lights, including the 1970s Thorn Beta 5 we've just seen, from start to finish. After about 5 minutes, the final colour of golden yellow is reached. And what is happening is that as electric current passes through the hot sodium vapour in the lamp, the electrical energy is absorbed by the vapour. This energy is then re-emitted in the form of light, which with sodium vapour is yellow. If you used other substances, you would get different colours, but yellow is close to the colour the human eye is most sensitive to. It's the start of evening. The sun has set, it starts to go dark, and it's lighting up time. And just imagine a whole area lit with SOX streetlights as shown in this speeded up computer simulation, where each lamp has an independent light sensor. When each individual sensor detects it is dark enough, it will switch one of the streetlights on, and if this happens over a range of time shortly after sunset, the result is a range of reds, oranges and yellows as the SOX lights warm up independently of one another. It's a colourful sight, and it's a local light show that is repeated at Twilight every evening. The type of weather affects when the streetlights switch on. Under a clear sky such as this, the lights will switch on at a later time relative to sunset. But if the weather is cloudy, rainy or misty, this will cause the sky to darken a little earlier, and if there is a shower, the light levels may fluctuate, so that the sky is darker, lighter, and then darker again. This could actually cause a street light to switch off and then on again later.
Let me now show you some lamps in my own collection, starting from the smallest. one is an 18 watt SOX lamp. So this is about as small as you can get. You can get 10 watts, but they're very rare. I bought this new in 2001, and it's the sort of thing you'd attach to the side of a building, or perhaps on having a residential side street. So that's 18 watts. Next one up is 35 watts. Now, this lamp is the same size as this one here. They're both 35 watts. But the difference is that this is an older design. This one is from the 1960s, whereas that one, as we've said, is more 70s or 80s. This was made by Ellico, and you can see it's a kind of boxier looking lamp, more of an old-fashioned design, also a little bit heavier as well. So that's a 1960s SOX lamp. Next, yes. This is a 55 watt lamp, and this is another fairly old SOX lamp. This one's from 1972, so I actually know the exact date of this. It is a Thorn Beta 8, and it's 55 watts. It's the sort of thing you'd use for a side road or maybe a main road. And now, getting to the bigger stuff. This is a 90 watt lamp, and it's also about 60 centimetres across, so that's how wide it is at the moment in my hands. This is a Thorn Alpha 9. This is a main road lantern from the 1970s or 80s. These were quite commonly used on main roads. So this is 90 watts. Still not too heavy at the moment. There's not a lot inside the lamp. Let's wait till we get to the next one. Now this is also 90 watts, but it's heavier. This is a GEC Z9454. It's 90 watts. It's 60 centimetres long or so, 65. And this weighed, I think, about 12 kilograms. But it was a bit hard to measure. I put it on the bathroom scales, and it was so big I could hardly read it on the display because it was taking up all the space. And this little beauty would be used to light main roads as well. This is from probably the 1980s. And you imagine this perched on top of a 6 metre tall column, or perhaps taller than that, 8 metres tall. At the top of that big lamppost, you've got this 12 kilograms swaying about in the breeze, or hopefully not. And this isn't even the biggest lantern in my collection. Well, it's the biggest in my collection, but you can get bigger SOX lanterns than this. You can get 135 watts, you can get 180 watts. The 180 watts are the biggest. I'm going to have to put this one down now.
So we've seen my own collection of a few of the common types of lanterns from the 1960s to 1980s, but they are just a small sample of hundreds of different models of SOX streetlights that have existed, as you can see from these photos taken by various street lighting enthusiasts from all over Britain. And here are some of the models you're most likely to see, all mostly dating from the 1970s to the 1990s. Philips have made SOX streetlights in large numbers for decades. On side roads you might see a 35 watt MI26 or a 55 watt MI36. While these Philips MAs are used on main roads, the MA90 is 90 watts, the MA50 is 135 watts, and the MA60 is 180 watts. The Thorn Alpha 4 is another favourite for motorways and main roads. And we've already seen the Thorn Beta 5, a 35 watt lantern used on side roads. It's probably the most commonly produced SOX streetlight of all. And even lampposts have come in a large variety of shapes and sizes over the years. They have been made out of cast iron, concrete, steel, aluminium, and even telegraph poles are sometimes put to extra use to hang lanterns on. Whatever their shape, lampposts are normally between 4 and 12 metres tall or between 12 and 36 feet.
So we've seen that SOX street lighting has certainly come in a wide range of different models over the years, and even the lampposts are available in an impressive variety. So SOX street lights have certainly found their use in the United Kingdom over the years, but what is the situation in other countries? Well, for example, in parts of northwest Europe, they've made use of SOX. Philips has lighting factories in both Belgium and the Netherlands, and so these two countries have used SOX on their streets. In fact, SOX street lighting has been developed in Belgium and the Netherlands certainly in the late 1970s and early 1980s. Germany has also made some use of SOX, albeit less so. Taking a different part of the country, a different part of the world in fact, over in Japan and South Korea, SOX has been used there. They found it very useful for tunnel lighting. The quality of SOX light has been good for that sort of application. And then, in a different part of the world again, in America, you can find SOX has been used. Now there they refer to it as LPS, which stands for low pressure sodium rather than SOX. But there are certainly pockets of this LPS lighting. For example, in Arizona, where they have many observatories, the astronomers there like to use LPS because it's good for filtering out the light because it's all one colour. Also in California, in cities such as San Diego and Los Angeles, LPS has been used there. In the state of Illinois, also in New York. In Chicago it's been used for tunnel lighting again, along with bridges and platforms. And also there's a retail chain there, at least one, that has used LPS as a form of security lighting. So although LPS hasn't been used widely in America, it has had its uses. In Canada, the eastern side of Canada has also used SOX. So you have Alberta, for example, the city of Edmonton, there's Toronto, and there's also Quebec. And finally, but certainly not least, is Australia. Now Australia certainly used to use SOX street lighting quite a lot, and again over there it's referred to as LPS or low pressure sodium. Now part of the reason why it was used so much there is because Australia used to be part of the British Empire, and so there were many suppliers of British streetlights over in Australia to the states of Queensland, New South Wales and South Australia, and cities such as Adelaide, Brisbane, Canberra, Sydney, Perth, Melbourne and Hobart. So although SOX streetlights aren't quite a fully global market, certainly over the decades they have had their global uses.
Of course, when it comes to street lighting, SOX is not the only option. There are a few alternatives available. For example, if you take your sodium lamp and simply increase the pressure, you get the high pressure sodium street lamp or SOM lamp. Now the key difference here is that the light given off is more white in nature, which makes it easier to determine the colour of different objects. And then there are other types. There's the mercury lamp, which used to be quite a competitor to SOX in the 20th century. There's the metal halide lamp, which is quite similar as a more modern development of mercury. And then there's LED. Now LED technology is quite a new technology and it's being developed all the time. I've got one here, simple LED battery powered light, fairly standard, but these are becoming ever more ubiquitous, and if you group enough LEDs together you get an LED street light. These are becoming more popular, and LED is certainly a real alternative to SOX.
But SOX lighting has many advantages. For example, it's very energy efficient. For the amount of energy you put in, the amount of light you get out is very high. Secondly, it contains zero mercury. Now this is important when you need to dispose of the lamp at the end of life. Other lighting sources mostly contain mercury, which is hard to get rid of without special consideration for the environment, but that's not the case with SOX. A third advantage, it's very effective in conditions of rain, fog and snow, where of course it's important to have good visibility. With other lighting sources that are white light, the light, when it shines through raindrops or fog particles or snowflakes, it can get diffracted and a little blurry, but that isn't a problem with SOX. A fourth advantage is contrast recognition between light and dark. And a fifth advantage is a lack of glare compared with other lighting sources. That's because of the elongated nature of a SOX lantern. A sixth advantage is in tunnel lighting. When you're driving through a tunnel, what you don't want is a stroboscopic effect if you've got lots of point sources of light. Because SOX lights are tubular, it's not so much of a problem having SOX lighting in a tunnel. A seventh advantage is that astronomers can easily filter out the light. So although yes, it contributes towards night sky pollution, it's monochromatic, it's easy to filter out the light. Another advantage is the low operating temperature, which makes it also easy to use with cheap plastic components, and these lamps are easier to service as a result. A light bulb might need a temperature of 2500 Celsius, but the SOX light, just 260. Also, SOX lights don't require a cooling off time before they switch back on if there's a power cut. Of course, when the power goes off and then back on, you want the lights to respond straight away. You don't want to have to wait. Yellow, the colour from the SOX light, is quite a nice cheery, warm colour, almost like a roaring fire on a winter's evening, so it hasn't got the coldness of blue-white light sources. Also, yellow is quite close to the peak sensitivity of the human eye. Now that's true unless the light levels are very low, but for most lighting conditions, SOX is quite close to the human eye's peak sensitivity.
So, will SOX continue to have a future? Well, that of course remains to be seen. But SOX does have many advantages as a light source, as we have seen, which will help to ensure its stickability. And even if it doesn't stick around, there are still quite a number of SOX streetlight enthusiasts, people who collect SOX streetlights, maybe buy them off the council second hand or buy them off each other, and also discuss street lighting in online forums. So whatever happens in the future, SOX is probably going to continue to be talked about for some time to come.